A body of mass 1 gram. So let me write here mass is 1 gram. So I am converting here itself into kilograms. Carrying a charge, so charge Q is equals to 10 to the power minus 8 coulomb. Passes from 2 points P and Q. So let's say that this is the point P and this is our point Q. P and Q are at electrical potentials 600 volt. P is at 600 volt and Q is at 0 volt. So charge is going from 600 to 0 volt. Okay. The velocity of the body at Q is, so VQ I am writing here as 20 centimeter per second. Okay. But here the final answer is in meter per second. So you have to convert 10 to the power minus 2 meter per second. Be very careful with the units, otherwise everything will go wrong. Okay. So you have to find the velocity at P. Okay. Let me repeat again, once again the question. The question says a body of mass 1 gram and carrying this much of charge is going from point P to Q. Okay. So if it is going from point P to Q, okay, the P has a potential of 600 volt and Q has a potential of 0 volt. What will be the velocity at point P if the velocity at Q is given here? So if something is going from P to Q, the total energy must remain conserved. Correct? What is the energy? The energy over here P must be equal to energy at that point Q. Okay. If ideally because there is no energy loss. Law of conservation of energy says that the net energy at point P must be equal to the net energy at point Q. Now what's your energy at point P? If the charge or this mass is moving, then it will have a kinetic energy and some potential energy at point P. That will be equals to kinetic energy at point Q plus potential energy at point Q. I hope this is clear. Anyone who has not understood, speak up. If something is moving from one point to another point, it will have some kinetic energy and it will have some potential energy. Okay. So the sum of kinetic plus potential at one point will be equals to the sum of kinetic plus potential on the other. What's kinetic energy at point P? Half mv square. And what about potential energy? Sir, potential energy, we have two formulas in our second chapter. One is K Q1 Q2 upon R. But here they are not having any Q1 Q2. Here we have potentials. So here which formula we will use? Charge times potential. Correct? So we will not use this formula. Okay, let me remove everything and let's continue here. So half mv square plus charge at point P times potential at point P. So QVP. The charge still remains the same. Charge is not changing when you are going from P to Q. So it will be half m. This is velocity at point P. This is velocity at point Q plus charge times velocity. Sorry, not velocity, potential. Be very careful with V's. This will be at point Q. Okay, great. Let's now substitute whatever stuff, we have to find what? We have to find the velocity at point P. So first, instead of substituting everything, let's take everything on the other side. So I am taking this QVP. Okay, we want half mv square now. So this will be half m Vp square will be equals to half m Vq square plus Q into potential at Q minus Q into potential at P. Now let's take this 2 and m on the other side. So velocity at P square will be equals to, multiply this 2 on the other side, it will be m Vq square plus 2, okay, Q Vq and minus 2Q Vp. 2 is going on the right hand side and this m I am taking on the right hand side, so whole divided by m. I hope this is clear. Okay. Now what we will do? Now we will simply substitute things. Okay. So let me first make it more simple. So Vp square will be equals to Vq square plus 2Q taking common Vq minus Vp whole divided by m. I hope this is clear. Now here we will substitute our data. Whatever information is given regarding this problem, here I will substitute it. Okay, so let's substitute the value. So velocity at point P square will be equals to velocity at Q. What's the velocity at Q? 20. So 20 into 10 to the power minus 2 whole square. Let's take it a little on the other side. Next is plus 2Q. So 2 times charge. What's the charge? 10 to the power minus 8. VQ minus VP. What's VQ minus VP? 0 volt, and this is 600. So let's take it minus 600. Why minus 600? 0 minus 600 whole divided by M. What's the mass? 1 into 10 to the power minus 3. I hope this is clear. Anyone who has not understood this red line, speak up. Okay, great. Now what we have to do next? We will solve Vp square will be equals to 400, okay, into 10 to the power minus 4, and plus, let's cancel out 10 to the power minus 3 goes up, it will be 2 into 10 to the power minus 5, and minus 600 as it is. Let's simplify further. So it will be 400, so let me write it 4 into 10 raised to minus 2, and here we can write it here as minus 6 to the 12 into 10 to the power minus 3. Great. So let's make it in a common power. So it will be 4 into 10 to the power minus 2 minus, okay, let me divide and multiply into 10 whole divided by 10. So if I multiply this 10 with this, this will become 10 to the power minus 2, and that will become 1.2. So this will be 4 minus 1.2. So let's see. So 10 minus 2 is 8, and 3 minus 2.8 into 10 raised to minus 2. That's our Vp square. Oh, so they have given in root itself. I thought we will have to calculate root. So that will be 0.028, right? So straight away we got our answer as option A.